right, ladies and gentlemen, so as it says up here, so far we've worked with quantitative data, right? Quantitative data means that it's numbers, right? And for example, weights of baby chicks or the number of videos, that's what we were looking at. So when you see the word quantitative, it means numbers. Now we're going to get into something called categorical, which means categories. And instead of my answers or my data sets, being numbers, they're going to be words, right? Favorite color, favorite pizza topping, favorite ice cream flavor. Those are all categorical, right? Your answers are words, not numbers. And we're going to skip exercise 1 because we're not together in class right now. But so sometimes we're actually comparing 2 different categorical data. So for example, we might want to know how a person's gender affects what profession they would prefer when they grow up. And to do that, we have a two-way frequency table. And what you're looking at here, so here are the 2 things we're comparing in this case, eye color and hair color. And we're going to look to see, is there any relationship between these? A correlation is what it's called. So when I look at this, it says how many students had blonde hair and blue eyes. So here's blue eyes, and I'm going to read over until I find blonde hair. So that was 4. Okay. How many students had red hair? Well, here's red hair, and here's your total. So we had 4 students total who had red hair. Now, the numbers by themselves don't always mean a lot to us. So what we can do is we can do what's called joint relative frequencies or marginal relative frequencies. This is basically saying what part out of the whole. And it can be done as a fraction, a decimal, or a percent. I'm going to do these as a percent. So you're going to take, we know we had 20 students altogether. There's my total of how many were answered. So I want to know how many had blue eyes and black hair. So that was 3 out of 20, which is, when I turn that into a percent, is 15%. So blonde and blue would have been 4 out of 20, which is 20%. Red would have been 1 out of 20, which is 5%. So the total of blue is 8 out of 20, and that would be 40%. All right? So for brown and green, I'm not going to fill in the out of 20s. Hopefully you see where I'm getting at. I'm just going to fill in the percents. So brown is 25%, brown and black. Brown and blonde is 10. Brown and red is 0, right, because there was a 0 there. And total for brown eyes is 35%. Green eyes, so we have 5%, and another 5%, and 15%, and then total of 25%. So my totals down here, so total people who had black hair is going to be 45%, and total people that had blonde hair is 35%, and then total that had red hair is 20%. And then this should always be your 100, because 20 out of 20, that's your whole. So this now can help us to eventually answer questions, right? Because now they're all compared to the same thing. Okay, so I know that the biggest category here, your most common, is going to be somebody with brown hair, brown eyes and black hair. That's going to be your most common. It's the highest percent. If you're looking at just inside the data and not totals. I know that blue eyes was the most common, but I know black hair was the most common, if you're looking at those. All right, let's see what else we can do with this. So we would like to understand associations or trends within a data set. In other words, please underline this, would a response to one category tell us something about a response to the other? And to do that, we use what are called conditional relative frequencies, where instead of comparing it to the total, you're going to compare to the row or column, depending on what it's asking. So let's see what that means. What is the conditional relative frequency of having green eyes if you have red hair? This is equivalent to asking what percent of people with red hair have green eyes. Okay, so we know there's a total of 4 people that have red hair, and 3 of those people had green eyes. So instead of comparing the 3 to 20, you're now just comparing it to the total number that had red hair. So this is now, if I do that as a percent, hopefully most of you know that, 75%. So if you have red hair, the probability or the chance or whatever that you're going to have green eyes is 75%. What is the conditional relative frequency of having green eyes if you have black hair? Well, black hair, there's a total of 9, and green eyes is, sorry, my pen stopped working. Green eyes is 1, there was 1 person. So when I turn that one into a percent, that's going to give me, I'm rounding to the nearest percent, about 11%. Okay, so that's where, and you can see there's a pretty big difference, but if you compare to the chart here, there wasn't that. There was a 10% difference, but if you're comparing them to marginal, now there's a much bigger difference. Does it appear that having green eyes has a dependency or at least an association with having red hair? Yes, because the percent of red hair and green eyes, helps if I can spell, helps if my pen keeps working, sorry, green eyes is much higher than other color hair. Okay, D, is it more likely that a person with black hair has blue eyes or that a person with blonde hair has brown eyes? So use conditional. So again, we have to kind of go back up. So I'm looking first with black hair, blue eyes. So black hair, we know we had 9 people. Blue eyes was 3. So this is 3 out of 9 for black and blue, which is a third, which is 33%. Or blonde hair has brown eyes. So blonde hair, we had 7 people. Blue eyes, we had 4. And 4 out of 7 is going to be 29%. Right? So usually you would look at that and you'd be like, oh, well, it has to be, you know, blonde hair, blue eyes. Well, it's actually not. Is it more likely that a person, so this one is more likely. It's a higher percent. All right, exercise number 4. A survey of 52 graduating seniors was conducted to determine if there was a connection between the gender of the student and whether they were going to go to college. Based on this data, what is more likely? Someone is going to college is female, or that someone who is female is going to college? They might seem the same, but they're not. So let's do the first one. We want to know going to college is female. So going to college, that's where you're going to get your total from, 29, is female, 13. All right, and that is going to give me 45%. The other one, someone who is female, so now we're looking at this total, going to college is the 13. So we're using the 13 both times, but we're comparing it to a different denominator. So this is 59%. So in this case, it is more likely that a female is going to college as opposed to someone who's going to college as a female. Right? And it's all depends on which one you're comparing it to. So this one is most likely. Okay, so this one isn't as much calculator work in terms of using your graphing calculator, but you still have to know how to change fractions to percents. So any questions, bring them to class and have a good night.